All right, welcome everyone. We would like to welcome all of you to this webinar today, which is a part of the EERI Younger Members Committee webinar series. Today's webinar will have 3 early career speakers who will talk about lessons learned during the Learning from Earthquake Travel Study Program trip to New Zealand in 2019. So a couple of webinar protocols. You are here now, so hopefully you figured out how to get your audio working. You can join using computer audio, or you can join via phone call. There is a panel for questions, should be on your right-hand side. This is where you can submit questions during the entire webinar. And please make sure that you specify to which speaker the question is. And I will be monitoring these questions today. I'm your host, Maha Inewi, one of the YMC co-chairs, and I will monitor the questions during the length of the webinar. And at the end, I will hold a brief Q&A sessions, and I will address the questions to the speakers. So a little bit about the Younger Members Committee. Our role mainly is to provide opportunities for early career professionals within EERI organization, both to advance their careers and to encourage them to become more active within EERI. The current co-chairs of the Younger Members Committee are Ezra Jampole, who's also one of our speakers today, myself, Maha Inewi, and Ashley Morales. The Younger Members Committee has a pretty diverse portfolio at the moment. We develop technical and social activities for younger members throughout the year and during the EERI annual meeting. We host webinars and we sponsor a seminar series at universities given by younger members, which we're currently looking at holding virtually. We also host an earthquake engineering blog on our website where early career professionals get to talk to a wider audience about their work in earthquake engineering. And we recently started a virtual program to introduce younger members to leaders in earthquake engineering. We also coordinate having younger members act as liaisons to other EERI committees and programs. If you're interested in joining the committee, please email us or join our website and fill our interest form. So today's webinar speakers, as I mentioned, we have 3 early career speakers who have been on the Learning from Earthquake Travel Study Program trip in Hulsey, Ezra Jampole, and Andrew Makdisi. We will start the webinar but with Caroline Urkiston from QuakeCoRE, the North New Zealand Center for Earthquake Resilience, who's been on the committee leading the trip to the earthquake to New Zealand for the travel study program. A little bit about Caroline. She's a deputy director of the Center for Sustainability at the University of Otago, and she's on the leadership team for QuakeCoRE. Her research is the nexus of geoscience and social resilience in the face of hazards, and she led the committee for the LFE travel study tour in 2019. Caroline, we're happy to have you today. Please take it away.
Tēnā koutou katoa, everyone. It's really lovely to be here, and I'm just sharing my screen now, so hopefully everyone can see that. It's a real pleasure to be here. I'm really excited to hear from these 3 wonderful young members of EERI about their experience in New Zealand. It was my great pleasure to lead the committee from the New Zealand end and worked with some wonderful people from EERI as we got the schedule ready for the study tour to New Zealand. So QuakeCoRE was partnering with EERI on this. It was a great collaboration. So QuakeCoRE has a vision for an earthquake resilience Aotearoa in New Zealand. And you can read the rest of our vision statement there. QuakeCoRE has been running for 5 years, and we're currently in the process of rebidding for another 8 years of work. And this is such an important cause, of course. New Zealand has had a number of recent earthquake disasters. That's exactly why the study tour came to New Zealand, because we had this wonderful living laboratory of places to visit which had experienced an event, a major earthquake disaster back in 2010 and 2011, obviously in Christchurch, but more recently the Kaikoura earthquake in 2016, which enabled the team to observe some very fresh impacts and consequences from that 7.8 earthquake. And then we moved, as I'll show you, we moved on to Wellington, which of course is the earthquake disaster of our future potentially for New Zealand. So this is our wonderful committee. We met for the first time in person in Christchurch a year ago, and it was wonderful working with this team. So we have Shannon Abling on the left and Laura Whitehurst, both based in New Zealand. Laura's a practicing engineer, and Shannon was finishing her PhD from the University of Auckland. And then, of course, Thalia and Agnos, and it was wonderful working with her and Zoe during the preparation for this tour. So, as I say, we began the tour in Christchurch, and everyone met for the first time one evening in various states of sleep deprivation from having flown long distances. And we enjoyed a nice meal together, and then kicked off these wonderful 5 days of experiences around Christchurch initially, and then we drove up through northern Canterbury into the Kaikoura district, and then up to Blenheim, noted there right in the top left corner of the South Island, before taking a flight in a little plane. Everyone noted it was a very small plane by American standards, into Wellington in the evening, and then spent a couple more days up in the city there. So this is the Christchurch Cathedral in the backdrop. You can see nothing much has changed here. There's still a lot of rubble at the end of the church in the background there. And we did a walking tour around the city as a starting off point to observe the rebuild, the renewal of the city of Christchurch. And on the right we see Thalia with our two directors for QuakeCoRE. Brendan's the director of QuakeCoRE, and David Johnson on the right is the deputy director. And that was at a mixer event that we had, which gave our participants the opportunity to mix and mingle with quite a few engineers, practicing engineers in Christchurch, as well as our academic colleagues from the University of Canterbury. Then we moved up towards the north and went into some rural parts of New Zealand, which I think was quite a highlight for some of the participants. And this is the famous Wall of Waio, which is the real epicenter of the Kaikoura quake. And this beautiful surface rupture came out of nowhere. We didn't know that this fault existed prior to the earthquake. And just a little further along from there was the Leader landslide, a wonderfully, well, dramatic failure of the hillside. It collapsed down into the river, the Leader River, and dammed it up. And this was great for the students and young professionals, because they had an opportunity to do some proper science and scanning of this face with one of the people from the RAPID facility up at the University of Washington. Then we moved on north to the coast, and the Kaikoura coast is one of the most spectacular parts of New Zealand. This was very early morning, just on dawn, and you can just see and feel the energy of this bunch that actually managed to get up early enough to see this beautiful sight. And it wasn't all about engineering. It was obviously, coming to New Zealand, it's about natural things, and this was a seal colony just up the coast from Kaikoura, where we stopped to look at the damage to State Highway 1, the major arterial route down the eastern side of the South Island. Major damage from landslides during that event, and you'll hear all about that, I'm sure, from the participants in a moment. And yes, it certainly wasn't all about engineering. We stopped at a lovely winery for lunch in Blenheim, and was able to observe some of the damage to the plant in this particular winery during the shaking, and also some of the efforts that they'd put in place to build resilience into their systems in the period since then. And then over to Wellington. So we were lucky enough to go up, well, one of the highest buildings in Wellington, just 22 stories high, and this is New Zealand, and walk the streets of Wellington City, and observe some of the risk reduction efforts that are going on in the city of Wellington, because of course it was affected by the Kaikoura earthquake in 2016, but it's got a long way to go to be resilient to what might happen in future. Wellington's a very at-risk city from subduction earthquakes beneath, just a few kilometres beneath the city, as well as some active faults in the area, including the Wairarapa fault, which produced the 1855 earthquake, the largest on record for New Zealand, at magnitude 8.2. So I'm going to wrap it up there. This is the wonderful group that travelled to New Zealand for the study tour. It was an absolute pleasure to meet you all. And I'm looking forward to hearing from 3 of our wonderful participants now. So haere rā from Aotearoa, New Zealand. That means goodbye for now.
Thank you, Caroline. That's a great introduction. We are looking forward now to hearing from 3 of the participants that were on the trip. We're going to start with Anne Hulsey. She is a PhD candidate at Stanford University. She has a master's degree from the School of Public Affairs and University of Texas, and performs earthquake engineering research focused on understanding damage to individual buildings and communities. And she has been involved in EERI for quite a long time and is serving currently on the board of directors for the EERI Northern California chapter. And we're happy to have you. Take it away.
Oops, I was muted. Just double checking, are you able to see my screen currently?
Yes, we can see your screen and hear you. Go ahead.
Okay, thank you. Sorry, I'm not sure why I can't. So sorry. Okay, so thank you so much, Caroline, for that introduction to what we've what we're going to be talking about. So the first thing that we're going to talk about, and what I'm bringing here to the table, is what we learned about what it looks like to rebuild the built environment. So we had 3 different groups. Ezra and I were on the built environment team, and then we also had social and economic team, and then Andrew is from the 3rd team, so I'll let him explain a little bit more what that one will be. But as we were looking at this, we divided what we were seeing into 2 things. One is opportunities in rebuilding the built environment, and then the other one would be challenges. So I have the easy job of talking about the opportunities. Ezra will have the hard one of talking through what challenges came out of that and how we could kind of address that further. So those on our built environment team, there was a total of 9 of us. Ezra is also on this, but then it was a great pleasure to work with the others who are listed here on the screen. So a little bit of background on these earthquakes. Caroline already said a little bit about this, but February 22 of 2011, there was an earthquake in Christchurch, right kind of under the heart of the city. This was following a previous earthquake that actually had a higher magnitude back in September. But because this one was so much closer to the city, it actually caused a lot more disruption. There was 2 building collapses. One of them was the CTV building. It had 115 casualties. Another one was the Pine Gold building. That was 18. It was really moving to be there in person, granted so many years later, but to see the spaces that they had created to kind of still commemorate these. There was this one area where there's a whole bunch of white chairs that had been set out as a permanent memorial, and the idea was that each of these white chairs was empty in memory of the people who had lost their lives. We also got to speak with someone who actually performed part of the not recovery, but the initial response to the Pine Gold building. She was actually there in the building she may have even be one of these people who's here on this roof, but it was just incredible to hear some of her stories of what it was like to sift through and try to find the people. It was really, really moving. Another thing that came out of this earthquake is that there were some widespread access restrictions due to safety cordons around buildings that were pretty heavily damaged. I was really glad to be able to be there in person and get to know a little bit more about how this all works, because this is actually what inspired my PhD research. And so to actually be there in person just kind of changed how I viewed all of that. So it was really great. So that was one of the earthquakes that we were there to observe kind of how the recovery went. But the other one, as Caroline mentioned, was the Kaikoura earthquake in 2016. This is a figure from Thornton Tomasetti. You can't see all the little writing there, so what I'm going to do is show a few of those annotations a little bit larger and show how our trip that Caroline just outlined actually perfectly aligned with these. So it was very intentional that we hit all of these. So one is that there was a lot of building damage in Kaikoura. We got to actually stop there. That was the scene that the beach picture was from Kaikoura. But on the way there, we got to go to the leader farm and see all of those ground displacements and the landslide that Caroline showed a picture of. And I think this was really, really moving for a lot of us because we got to meet the wife of the husband and wife team who run the leader farm, and just the way in which she spoke about their experience. The landslide actually covered their power plant and their water supply, and just the way in which she discussed how they bounced back from that. I think that was probably the biggest thing that I took away from what resilience means. And many of us were joking about how we would want to come back and be an intern at their farm. I'm not sure that it was all entirely joking for everyone. That was really, really fun. And then, of course, there was the damage to the wineries in Marlborough that Caroline also mentioned. We took it upon ourselves to go and observe that, what went on by partaking of the wine at one of the wineries. So that was good fun to all do together. And then we ended by going to Wellington, and Ken Elwood took us on a tour. A few other people as well took us on a tour to see the aftermath of that, both what happened to specific buildings that were damaged, but also to talk about subsequent efforts that have been made to make the city safer for a future earthquake. So one of the big things that came out of that earthquake was lifeline damage in and out of Kaikoura. So all of the highways going down the south eastern edge of the South Island were completely closed off. You can see that in the right figure here. And so Kaikoura actually was inaccessible by road for up to 6 months. And then they got, I think it was the southern direction got opened first, and then another 6 months later, the northern direction were opened. So it was really, really affected that town, but also all of New Zealand's transportation system, and making sure we could get goods and things across. So it was really, really impactful. And so as I talk now about the recovery, I want to frame it based on something that was discussed in the National Civil Defense Emergency Management Strategy, which is where they're talking about what it means to have recovery. And the 3 R's that they talked about in this space were risk reduction, readiness, and response. So our conversation currently about the built environment is going to focus mostly on risk reduction, but also the way in which you structure the built environment can contribute to readiness, which is making sure that in the event of an earthquake, you are ready and prepared to act as necessary. And then the response would be making sure that you're able to really enact and move forward with all of those efforts. But we're going to focus primarily on risk reduction. And the 2 opportunities that we observed in this were, 1, to rebuild with enhanced structures, and 2nd, to reconfigure the built environment. So with regards to rebuilding with enhanced structures, one of the things came out of this is that there were updated hazard maps. As Caroline mentioned, it wasn't even known that there was that fault that showed up on the leader farm. So there's a lot more information that came out both after the Canterbury earthquake sequence and then even during Kaikoura about what the hazard really was. And so one of the things that came was that the earthquake hazard maps were distinctly changed from before and after the Canterbury earthquake sequence. That's the one that was going on around Christchurch back in 2011. So you can see here the dashed lines are the old version. So here are the old response spectrum that would have been used in design, and then the solid lines are the new and updated ones. And you can see that's a pretty significant increase there. Secondly, there were updated provisions for hollow core slab construction. This is the statistics house, which is in Wellington, and you can see here in the blow up of one of these windows that essentially the floor of one floor fell down onto the next floor, and it was because of this hollow core slab construction that wasn't quite detailed appropriately. And in order to address that, there was various detailing design requirements that were put in place. This is just a list of some of them. I'm not going to talk about them exactly, but just to say that this was an important thing to recognize. It had already been recognized before, but this really highlighted how significant it was and made sure that those provisions were updated, and it became apparent as to how important they really were. Another thing is to start implementing low damage technologies. So this is a picture of the Rehua building on the University of Canterbury campus. This, instead of being torn down, it was retrofit, and the way in which they did that was to use viscous dampers and buckling restrained braces. So here you can see one of the viscous dampers, and then here you can see a buckling restrained brace. And it's been interesting to see how in the aftermath of the earthquake, New Zealand was really ready to start embracing these new technologies. There's been speculation that in the States, if this were to happen, it would be a little bit more difficult to embrace innovation quite as easily, just because of the way that our codes work and things like that. But it was cool to hear how this was addressed in New Zealand. Another thing is that a lot of people started using base isolation. So here on the waterfront in Wellington is an example of that. So I put in these red lines here so you could see what we're talking about, but this is basically right around here on the left picture, down on the ground. And it's an isolation gap that you really wouldn't see if you didn't know to be looking for it. But in the event of an earthquake, it allows the building to slide with respect to the rest of the ground, and these pavers would actually pop up and move so that the building could move with respect to the other part of the ground. On a personal note, this walkway was an interesting one for me to remember, because this is where I first started talking to Ken Elwood, who was there from University of Auckland, to give us this tour. And that conversation has since led to, I will be doing a postdoc after I finish with him. And so that's just a plug to say these are really, really important. These EERI events, including travel study programs, are really, really important ways for us as younger members to really get involved. Even if you can't go on a travel study tour, it's great to go in person to the annual meetings. I went in 2015, was the first one that I ever attended. I didn't know a single person. I didn't go with anyone from my university, but the way in which I was welcomed, even though I didn't have anything to offer, I didn't have a poster, it was really quite incredible. I still talk with some of the people who I met there. They're well known in our field. I also joined the public policy committee at that time. It was an open committee, and so I went and joined, and because I've continued to stay with them, I actually was invited to be part of planning the policy track of last year's, in March, we had another annual meeting and we had a policy track, and I was invited to be part of the planning committee for that. So given that this is a younger members committee discussion, I wanted to put in that plug and say it really is a great way to engage with our organization, and EERI and members of EERI are wonderful at bringing in and welcoming younger members. Back to the presentation. Another thing, in addition to all the buildings, there's an opportunity to rebuild with enhanced infrastructure. So I mentioned that all of the lifelines, those roads are what I showed you, but also there was issues with power and cell service and things like that. And so that was a big effort for how they would address and rebuild those roads. But one thing that they recognized was that you can't necessarily prevent any damage in subsequent earthquakes. And so they wanted to incorporate a design that would allow for quick recovery of road networks if, in fact, there was damage to them. So try to make them less damageable, but also in the event of damage, how can we get them back on board more quickly? And so it was interesting. We got to go and talk with the people. They drove us on a bus and showed us various things on this tour, and so, or on this road. And that was really fun to see. One of the things that we were all struck by was that on this particular image, what we see here is the road that was built up pretty significantly, but then there's this culvert here. And one of the purposes of that culvert is that when you have the landslide coming down off this hill here, it actually lets it sweep under the road instead of having the road dam that and cause a lot more problems. There was another more heartwarming reason for that culvert, but I'll let Andrew talk about that in his session. So we've talked now about the opportunity to rebuild with enhanced structures, ones that won't be damaged as easily, but there's also, in the aftermath of the earthquakes, when there really was a significant amount of destruction, and so then as you're rebuilding, you have to figure out what is it that we're going to rebuild. And so there's this opportunity to also reconfigure the built environment. And so we thought a lot about what opportunities are there in that space in order to reduce risk. So one thing that Christchurch did is that they built this emergency operations center. This brought in a lot of different groups, the police, emergency operations, I think City Hall is now in here, or the city management. But in terms of making sure that this was an enhanced structure, they also wanted to protect it so that they're able to use it afterwards. And so at this line here, that's all base isolated. So again, just making sure that the buildings that are being built for these purposes are going to have low damage. But really the benefit of this is that all of these groups are already working now before an earthquake that will come in the future. And so they know how to work with each other. They know what each other's needs are. They know who to talk to and who's the best person to ask for various things. And so that's been really cool to see how by reconfiguring the built environment, bringing everyone into the same building, they're really enabling their readiness, which was another one of the R's of recovery, making sure that we are ready to respond to an earthquake. Another thing is that this is the new Tauranga Christchurch Public Library that was built. It was opened fairly recently before we arrived last year. And the way that this was envisioned was that it's almost like the living room of the city. And what it did was bring in people from outside who have been living in the suburbs and haven't really been into the city center since the earthquake because there was no life in the city center anymore. But now that they have this library, almost immediately they started discovering that people were coming back to the city center. People were bringing their kids to play with the really incredible kids exhibits there. So it was really interesting and beautiful to hear about this, how they were so intentional about creating this community living room and how it has in fact been really impactful. But again, this needed to be done with enhanced structures. And so what they did here was that they have shear walls. On the right picture here, we see a shear wall on the left and on the right. And then they let these rock with respect to each other so that when you get a lot of movement in the earthquake, there aren't rigid connections that are going to break. Instead, there are these U-shaped fuses, which they are going to accumulate all of the damage. And then because they're open and readily accessible, those can be replaced after an earthquake. So I mentioned that the library was an opportunity for a public living room. This is more an opportunity for a public backyard. So the red zone that you see here on the left is where there was a whole bunch of residential housing that, because it was so close to the river, which you see kind of winding along through here, because it was so close, it was actually built on soil that was liquefiable. And so that was really quite dangerous for anyone to continue living there. And so Christchurch, they went ahead and bought up all of that land and relocated the people, and they've now been trying to figure out what to do with that land in its place. And so we went to an engineering firm that has been part of visualizing what that might look like. And we got to do a virtual reality simulation where we went around in this little kayak to see what this might look like. But the intent is that it become this regeneration plan that you see on the right, where lots of people be able to come and enjoy this space in a safer way than what it used to be, which was to have people living in this potentially dangerous location. So again, what I've discussed is the opportunity to rebuild with enhanced structures and to reconfigure the built environment. And both of those are ways to handle the risk reduction portion of preparing for and anticipating recovery. But as I also said, it really prepares, gets us ready for the readiness aspect that will be coming, make sure that we're thinking about and addressing and working together to make sure that all of those aspects of recovery can move forward the next time this comes around. So thank you.
Thank you, Anne, very much for the great presentation. I'll remind everyone that you can post questions to the questions panel anytime during the webinar. Please make sure to specify to which speaker you would like to address your question. And I will now welcome our next speaker, Ezra Jampole. Ezra is a managing engineer at Exponent in New York City. He works and specializes in performance assessment of structures subjected to extreme events, and he served as a consultant on a lot of projects assessing the origin of damage to structures. Ezra has his PhD and master's degree from Stanford University and bachelor's from Northeastern University. He has been involved with EERI for quite a long time, and he's currently one of the co-chairs of the Younger Members Committee. Ezra, good to have you today. Take it away.
Thanks, Maha. Can you see my screen?
Yes. Very good.
Okay, great. Thank you. Okay. Thanks, Maha, and thanks to Caroline and Anne for providing excellent introductions. I do want to address what Anne said, that I have the difficult task of talking about the challenges in rebuilding the built environment in New Zealand following the earthquakes, and I wouldn't necessarily use the term difficult. Perhaps unenviable is more appropriate, but I do want to add the caveat that a lot of these challenges are not just critiques of the way that New Zealand has rebuilt, but they're mainly challenges that are presented when anyone has some sort of a disaster that they're trying to recover from. And these are specific to earthquakes, but I think a lot of the ideas probably apply to other disasters as well, perhaps ones that we're living through right now. First, I want to acknowledge collaborators on this, first Thalia Anagnos and Caroline Orchison for organizing the EERI travel study program, and then the other people who were part of the built-in environment team, including Anne. So what do I mean when I talk about challenges in post-earthquake recovery? Well, there are a lot of different things that are challenging when you recover from an earthquake or any disaster. And you really need to address all of them. And I think it goes beyond this list, but perhaps these are the main ones that we see on display in New Zealand. And so the first is minimizing disruption. So how do you recover quickly? How are you able to reuse the space that has perhaps temporarily and perhaps for quite a long time become inaccessible or unusable with its original purpose because of the earthquake? How do you deal with insurance payouts? How do you get money to people who need it so that they can rebuild and recover? How do you reconfigure the land? Anne gave some really good examples of how land is used more effectively now, taking people out of areas that are more prone to flooding along the shore. But it's not all rosy sometimes. It can be quite challenging to figure out exactly how you should use land after an earthquake. Are we equitably allocating resources? There is finite funds, despite what the Fed may say, when you need to recover from some sort of disaster, and you can only spend them on one thing or another, and there's a pull and a push, and we need to make sure that these are being allocated in a fair and equitable manner. Incorporating new technology in the building stock is also quite important. There is a lot of research going on, but you need to make sure it's adequately tested and that there are protocols in place so that you can incorporate new technology into the building stock and recover better with structures that are more resistant to damage from earthquakes. And finally, how do you design retrofit programs that meet all the needs and balance what people can put into their structures with the need to have more resistant structures and more resistant, more resilient cities? So we'll take these on one at a time under various headings. So the first thing I want to come back to is the red zone land that Anne talked about. These were areas mostly around the Avon River that were subject to liquefaction or lateral spreading. And this was quite a problem in Christchurch. There were about 8,000 residences that were in the red zone. So as you recover as a community, you've lost 8,000 units of housing in a city of only about 400,000 people. That's actually quite significant. And this is land that it's essentially been deemed uneconomical to build on again. So that's a permanent loss of space that you would be able to build more housing on. Another area related to being able to use space again and minimize disruption is related to Cordons. Now, Cordons have a lot of benefits, and Anne touched on this as well, that you weren't able to access parts of the city center for quite a long time after the February 2011 earthquake. So there are certainly short-term benefits of Cordons. There's easier unimpeded access for first and second responders, and then some long-term benefits as well, that you can commence repairs without simultaneously trying to keep a large space functional and open to the public. It makes things a little bit easier from the construction perspective. And then also, when you close off this large space because you're repairing, then you can look at the space holistically and decide exactly how you want to repair the space in tandem, despite some push and pull from various stakeholders within the cordon. But cordons are extremely disruptive. So there were about 50,000 central city jobs that were displaced because of the cordons. And 32% of the businesses had staff that were temporarily forced to relocate. So not only are those businesses relocating, other people in their homes are also potentially relocating. And many of them were permanently relocated. And of those people who were relocated, about 80% of them worked in the CBD. So in combination of seeing the red zones and seeing the cordons and other damage around Christchurch, seeing a very large percentage of the economic engine for the region being displaced. And the cordons are also a challenge because once you've cordoned off the area, even if you have a building that's functioning, you can't access it yet. So ultimately, about 70% of the buildings in this cordon region were ultimately demolished. And it took about 2.5 years until I think June of 2013 for the cordons to be opened up again and cordons to be removed. So these cordons are something that we need to be thinking about beyond just Christchurch, beyond just earthquakes in New Zealand. This is a study by Anne and her advisors at Stanford that looked at an earthquake scenario from magnitude 7.2 on the San Andreas Fault in the San Francisco Bay Area. And they looked at recovery, so the amount of commercial, in terms of the amount of commercial office space that was available relative to what there was before the event in a certain number of days after the earthquake. And what they found is that if you don't include things like cordons that affect not only the damaged buildings, but the undamaged buildings that are in regions and areas of the city that are heavily damaged, the recovery looks quite different. It happens much slower, and you lose a much larger portion of your office space, and thus your economic engine. And it just takes quite a long time to recover. So it's quite important that we consider things like cordons when we look at the resilience of a city. So another challenge is how you deal with insurance. So for a little bit of background on homeowners insurance in New Zealand, nearly all homes have earthquake insurance, which is great from the perspective of homeowners who have some financial backing if there's damage from an earthquake. And this is quite in contrast to California, where we're probably less than 10% of homes with earthquake insurance. But the way the earthquake insurance is set up has potentially caused some issues after the earthquake. So there is a government program through EQC that funds up to about $100,000 of damage from the earthquake, and then supplemental private insurance picks up any damage beyond that threshold in an event. Now, there were so many earthquakes in quick succession from September 2010, February 2011, June 2011, and December of 2011, and a couple other ones as well, that there wasn't time to actually inspect all of the homes in between every single event, particularly between the first earthquake in September of 2010 and the second earthquake in February of 2011. So then, if you're looking at a home after it's been damaged by an earthquake, but you don't know what the state was before when it was potentially damaged by another earthquake, then you don't know who should be paying out. And as a result, there has been disputes between the insurers on how you apportion damage between the events. And this can unfortunately lead to delays in payouts and delays in repairs as well, which slows the recovery of the region. And housing is obviously quite important. You're not going to have people return to the city center unless they have somewhere to live in the area. So another important factor is how you're rebuilding and how you're reconfiguring space. And Christchurch has really done a nice job of becoming denser and removing some of the structures that were quite vulnerable in areas of liquefaction and areas near the river. But there are some issues, and I want to highlight one of those issues by a photo that is, I'll call it today. It wasn't taken today, obviously, and I want to note that this is pre-pandemic, which I note because it's quite empty. So in this photo, we see from the CBD, almost no one is on the street. It's around lunchtime, very wide roads, beautiful bike lanes, and no one's using them. No one's walking around, and that's an issue. You know, we want space to be used effectively. And part of the problem has been that Christchurch has taken an approach of sectoral redevelopment. They essentially have this top-down approach where, based on the way that the land is being used, they're zoning it that way. And the problem with this is that you then don't have mixed use. And the result is that there's very little or no residential construction in Christchurch CBD. And this results in ineffective use of the space. And perhaps I'm particularly offended as someone who lives in Manhattan that there isn't mixed use. There aren't residences and businesses and other commercial space and retail and restaurants all right next to each other. That we're missing that big component of housing. But I think that it's really hindering the recovery of cities when you have one but not the other, not effectively using that space. So another issue is how resources are allocated after disasters, particularly after earthquakes. And I'll highlight two contrasting cases here. And so one is the Christchurch Cathedral, which I believe still looks roughly like this. So this was damaged in the earthquake, and the church decided after the earthquake that they were going to demolish the cathedral. And it, on the face of it, seems like a reasonable decision, considering how heavily it's damaged. The issue is that that church was really a staple of Christchurch. The community felt quite a connection to the church, and public funds had gone to maintaining the church over the years. This would be a private entity making a decision on, well, perhaps a quasi-public asset. At least the public is involved in it, and certainly has a stake in the church remaining there. And so this led to legal disputes. And it's finally been resolved in the last few months. The church will be rebuilt in a public-private partnership. And so this is something I want to contrast with Wellington Town Hall, which has been closed since the 2013 Seton earthquake in Wellington. And this is a performance space. It's well known in Wellington. The Beatles perform there, so it must be kind of famous. And this has been closed for seismic upgrades, and the plan currently is to install screw piles and seismic isolation. But I want to add that is quite expensive. I think the estimates now are over $100 million as the minimum that it will take to repair Wellington Town Hall. But is that the best use of funds? It's a performance space, will primarily benefit people who are a little wealthier. But there are competing needs. For example, tsunami awareness, since Wellington is highly vulnerable to tsunamis, or retrofits to URM buildings. These are areas that probably could use more funding, and there's a lot of money going to a space that primarily benefits the wealthy. So there should be some consideration for balancing where resources go after earthquakes and making sure that everyone is represented. So one other area I want to touch on is related to implementing new technologies, and these are challenges that New Zealand has largely come to meet. Anna has pointed out that a lot of new technologies have been used in buildings after the earthquake, including seismic isolation, which I hesitate to call new since they're patents over 100 years old on isolation technologies, but fluid viscous dampers, BRBs, the U-shaped flexural plate in the library. And getting approval for using these can be challenging. It's more of a hurdle than a conventional technology, especially in the U.S. But it's something that New Zealand has done a pretty good job of trying to incorporate these technologies. The one potential challenge is that with the new technology, it hasn't been through a lot of earthquakes around the world of different types. There's been testing in the lab, perhaps. Maybe it's gone through one or two events, but until we get the earthquake that happens to target that type of system, we don't really know how it'll behave. So this perhaps is my chance to advocate for more funding for experimental work in earthquake engineering. And another point related to low damage systems is that it's really great to improve the way that the building stock performs during an earthquake, but sometimes we need to step back and think about, is this doing what it's intended to? So here on the right, we see some tsunami hazard maps that essentially in the colored area, in the red, orange, and yellow region is where there might be some inundation, particularly close to the shore. And right near the shore, there have been numerous new base isolated buildings constructed. Now, you use a base isolated building when you want to minimize or limit damage to the structure, and really you want the structure to be inhabitable and a usable space immediately after the event. Now, if the tsunami comes, and in theory it takes out the first story, so the water just goes underneath the building and doesn't really damage the isolated structure, is that space still usable? Well, there certainly is going to be widespread destruction if the tsunami has come to the site. And I would question if some of the lifelines and utilities will still be useful, and if some of the services will still work in the area. And so we're really getting what we're paying for with base isolation. So a last point I want to touch on is related to retrofit programs. And New Zealand has taken an interesting approach, and it's largely because retrofitting a building is quite expensive. So bringing it up to a code standard costs more than constructing a building from scratch, sometimes 30 or 40% more. So it often doesn't make financial sense to bring it up to the new building standard. You probably would just demolish it. And so MB has enacted this methodology to identify the buildings that are most prone to earthquakes and then assign a percentage to them. What percentage of the new building standard is that building? And anything that is below 33%, a third of the new building standard, you need to retrofit to build up to 33% of the new building standard. So this is great because we're getting better buildings, we're retrofitting ones that are most vulnerable. The problem is that this is still well below what the equivalent safety level is in new structures, which we tend to think will perform better during earthquakes. And it still can be quite costly as well to do this. So that's a challenge that is faced with retrofit programs. So I've presented a lot of challenges and have offered limited to no solutions on how we address these challenges, but I'll give my 2 cents now on how we can address some of these challenges after earthquakes. So one, prioritizing the review and retrofit of buildings that, if damaged, will impact the use of surrounding buildings. Cordons are very important. You can shut down a very large city center by seeing damage to only a couple of structures, and this really can destroy the economic engine of those regions. I think we need to encourage mixed-use redevelopment. Let's make sure we're adequately using these spaces, that we have residential units, that we have office space, that we have restaurants, that we have commercial space. The mixed use will really contribute to the vibrancy and resilience of that community. And let's make sure that all stakeholders are represented. We need to make sure all the diverse stakeholders, and I'm talking mostly about economic diversity as well as New Zealand in particular, diversity, including the Maori, make sure they're all represented when we make decisions about recovery. We need more research into low damage systems so that we can implement them and we can improve the quality of the building stock. And finally, we need further study for how and for how long building should be used, and that should really inform the retrofit programs that we have for where it makes sense to retrofit and where it might make sense to have a new building. So I hope that has not been too critical of New Zealand, really trying to offer suggestions of how we can meet challenges in future earthquakes and recover successfully. So thank you.
Thank you very much, Ezra. That was a great presentation. I'd like to introduce our next speaker, Andrew Makdisi. Andrew is a PhD student at the University of Washington. His research focuses on soil liquefaction and ground failures that happen during earthquakes. Andrew has received his bachelor's degree from the University of California, Davis, and master's degree in civil engineering from the University of Washington. And he has been involved within EERI for a while, and he serves on the board of directors for the Washington professional chapter. Thank you, Andrew, for being with us today. Take it away.
Okay, hi everybody. Can everyone hear me?
Yes, we can hear you and see your screen.
Excellent. Great, yeah, thank you for for the kind introduction, Maha. Thanks everyone for being here today. Hope everyone is staying safe and healthy. And thanks to the YMC for inviting me to speak today. So the first couple of presentations you've heard today have been sort of, I don't want to say entirely structural focused, but they have sort of been focused on what I will call the built environment. So it's kind of my job to sort of present the environmental side of things. There, as we know, there's kind of an environmental impact to everything we do, and even more so when natural hazards such as earthquakes occur. So my discussion with you today is going to be about the environmental impacts of the 2010-2011 Canterbury earthquake sequence, as well as the 2016 Kaikoura earthquakes. This is some of the lessons that my LFE study group, kind of key observations we took away, and some lessons learned moving forward. Before I sort of dive into the real meat of the presentation, I'd like to acknowledge first and foremost Thalia and Caroline for their efforts both stateside and in New Zealand. This really doesn't come together without their hard work, as well as the hard work of Zoe, Laura, and Shannon. I'd also like to acknowledge my group members, Meg, Z, who Facebook is correct. I think it's Z's birthday today, so if Z's on this call, happy birthday, Z. And then Ribu, Kristen, Yolanda, Shin, and Claire. Basically everything I'm giving to you today was a group effort, and so I'd like to acknowledge them before moving forward. Okay, so as the title states, our study group focus was on the impacts of the past decade or so of seismicity in New Zealand on the natural environment. Specifically, we wanted to evaluate these impacts through the lens of long-term recovery and resilience, and that's through a framework established by the New Zealand Civil Defense and Emergency Management, or CDEM. The components of this framework are as follows: the social, built, economic, and natural environments. And the reason I went counterclockwise starting from top is so I could kind of highlight natural environment last. It's important to note, at least on the little sort of Venn diagrammy figure on the left, is that all of these are kind of linked to each other in some way, and they're also obviously linked by the central focus on community, and how community can't really exist without these four components. But within the natural environment specifically, the CDM outlines sort of four focus subdivisions, all once again of which are highly interrelated. We have biodiversity and ecosystems. This is, flora and fauna, natural resources such as water, handling of waste and pollution, and amenity values. And these are things like public parks, green spaces, and national parks. These are the sort of, all of these sort of exist at the interface between the built environment and the natural environment. So through that environmental lens, I'm going to share with you some of the key observations, non-comprehensive list that our group decided to highlight from the Canterbury sequence and Kaikoura earthquakes. And we sort of use some of these lessons to develop some broad-ish recommendations for fostering more resilient communities from that standpoint. Although I think a lot of these recommendations can sort of be applied to other community components as well. So I am a geotechnical engineer, and so if I didn't start with liquefaction, then I really wouldn't be doing my job. There are a lot of ways to represent the severity damage of the liquefaction damage that occurred in Christchurch from the Canterbury sequence. The figure on the right is really one that probably does it best. I'm going to bring up my laser pointer real quick. I'm not sure if people can see it. Sort of outlines really the moderate and severe areas within Christchurch that were affected by the liquefaction. Another statistic that really stuck out to me was the amount of surface ejecta that needed to be off-hauled at all of these liquefaction sites. It was estimated to be about 900,000 tons. I did a back of the envelope calculation a few months ago that I never really double checked, but let's call it enough to fill the Colosseum in Rome about 40 times over. That's the volume of material that needed to be off-hauled. That amount of earthwork has a significant carbon footprint, as you might expect. You're operating heavy machinery, you need to transport a lot of material to potentially very distant areas. And so this process, along with The rest of the demolition work that occurred throughout Christchurch on buildings contributed to significant short-term degradation in air quality throughout the greater Christchurch area. That is an environmental impact that also impacts human population as well. To sort of focus more on the areas most severely affected by liquefaction near the Avon River, this is an issue that both Anne and Ezra brought up earlier. This is an area where numerous homes needed to be demolished, and this is what the land looks like today. It's still an extreme liquefaction hazard zone. There is not, and I don't believe there will be plans to rebuild homes here, but it's a pretty nice looking area. And there has been a lot of discussion about turning this region into a green belt, public park space, and that sort of goes back to this idea of amenity value. Can you increase this amenity value in an area where you can't really build out human infrastructure otherwise? We are still a decade in, and its fate hasn't fully been decided by local government, but this is one of those examples of ways to salvage kind of amenity value out of a very high hazard area. The liquefaction and lateral spreading also heavily impacted waterways, kind of the third big component of liquefaction in Christchurch. Water quality was adversely affected by increases in suspended silts and sediment, as well as, I think more critically, ruptures to very large sewage lines. And so for humans, sewage line ruptures is extremely inconvenient. I mean, especially in this area, 2-month boil notice is not a fun way to go through life. That being said, the impacts of widespread sewage ruptures on aquatic ecosystems, both wildlife and flora, were significantly more severe and more long-term. And this is an example of evaluating these hazards in terms of how they impact our biodiversity and ecosystems. Moving past liquefaction, there were numerous instances of land damage in the 2016 Kaikoura earthquake. Zooming in on a couple areas, we wanted to highlight, as Anne did earlier, the impacts of widespread landslides, as well as surface fault ruptures on a sheep farm in Kaikoura. As Anne said earlier, one of the more spectacular features was the leader landslide, which buried and destroyed the farm's pumping system that supplied water to all of their farm animals. One of the interesting features of this kind of resilience case study was that the distribution system was eventually replaced by a more reliable and more efficient gravity system. And this is a really neat example of taking the opportunity to build a more improved resilient system when given the opportunity. This did, however, take 3 months to be fully operational, and that really put a strain on the farm's ability to kind of get back up and running. But still, a really interesting example of what is known as building back better, was kind of the buzzword that we threw around a lot that week. Another case study was the large landslide north of Kaikoura at Ohau Point. In addition to the damage to the roadway that you can see, there was a roadway, it was completely buried, and in addition to that kind of impact on human infrastructure, the inability to access that road for months on end, the landslide also buried a known seal nesting ground right after breeding season. I was actually going to move forward with a picture of seal pups, but I thought that was just a little bit too difficult to put people through emotionally. But this was right after breeding season, and an estimated 1,500 seal pups were thought to have been at risk, although we don't know exactly what the final casualty count was. And so this presented another opportunity for rebuilding the roadway to accommodate both the needs for the local human population and wildlife. And so what you're seeing with that little culvert there, that was built specifically to allow the seals to continue to access the sea from their what was then buried breeding ground. And so it's one of those things that everybody kind of wins a little bit. Okay, so those were just a few examples of how seismic hazards that engineers and officials really spend a lot of time worrying about can impact the natural environment in ways that we may not typically consider during that planning and design stage. We might worry about things like short-term service interruptions or road access for human populations, but I think it's really important to be able to dig a little deeper and understand how these types of vulnerabilities in our critical infrastructure and in the built environment can eventually transfer that risk to the natural environment. So with that in mind, we can take some of the lessons learned that I outlined in the previous slides and use them sort of to broadly inform policy moving forward. The first recommendation that our study group really focused on was understanding our hazards and consequences to those hazards. And really, more importantly, understanding, well, not more importantly, as importantly, understanding the uncertainties, kind of the upper and lower bounds of those hazards and consequences. And this one might feel obvious, pretty obvious, relatively basic, but it's really important to note that both Canterbury and Kaikoura featured ruptures of unknown faults that were near populated areas. This is a challenge. This will always be a challenge in hazard characterization. It's the idea that hazard perception is constantly evolving. We need to be able to continue to invest time and money into investigating and characterizing our hazard space. So on an individual level, that might look like with seismic hazards, continuing efforts to map faults, understanding connectivity among faults. It also consists of extracting meaningful data from previous earthquakes to inform hazards assessments in future events, such as the landslide inventory from Kaikoura that came out of the 2016 event. We also need to be able to consider vulnerabilities from sort of an ensemble of potential hazards, not just earthquakes. And we also need to be able to consider how the combination of two or more hazards might increase the severity of a particular consequence. So going back to our landslide example, the Dello et al. Study that I referenced in the previous slide recognized that even though earthquakes were the primary cause for landslide occurrence in Kaikoura, there is an additional ongoing risk to long-term stability due to the possibility of large rainstorm events. And this is the type of mechanism that a single hazard approach just doesn't sufficiently capture, potentially in areas that are prone to multiple types of natural hazards. And I would argue that almost every area in the world is prone to multiple types of natural hazards. If we can take one more step back from this multi-hazard perspective and consider how hazards can lead to impacts on the land and its assets, we arrive at a system level approach where we need to be able to consider community impacts as a whole, understanding the interdependencies between the natural and built environments, and consider how multiple hazards might affect those aspects of the community. So that was sort of the general framework of the approach. One of the specific applications I want to highlight could be the protection of local fauna. These types of measures would involve coordinating with environmental agencies to identify areas where vulnerabilities in our built environment might impact local fauna. This is bringing in more stakeholders, more broad areas of expertise to approach this problem that we really might typically just start and end with evaluating the infrastructure vulnerability without looking at the environmental sort of cascading impact. Another would be recognizing that wildlife sanctuaries and reserves are an extremely critical part of not just amenity value, but the natural environment itself. So evaluating infrastructure in sanctuaries and reserves, employing pre-disaster strategies by working with those managing these types of sanctuaries, communicating the risks to them. These are all really important steps that we can take. And it consists of really just reaching out, picking up the phone or emailing people and just establishing the contact and starting the conversation. You can also approach this from the natural resource side of things, specifically water resources. Obviously, we want to be able to identify those critical lifelines and assess their vulnerabilities. Again, not just to human populations, but to the natural environment, and understand their direct impacts. Again, not just the damage and repair costs, but what is the long-term impact to biodiversity in a particular aquatic environment. Obviously, we need to be able to prepare contingencies for service gaps to local residents. That's keeping the human population involved. Looking at sort of the short and long-term resource impacts on water quality that I alluded to earlier, and debris disposal, as I mentioned, probably in one of my first or third slides or something, hard to keep track. We talked a little bit about how that was such a huge operation in Christchurch. One of the ways to lessen the impact of debris disposal is to look for ways to minimize transport of rubble, ensure that disposal areas are up to environmental standards, and to look for ways to reuse materials. Okay, so coming back to a broader view and how we might implement these types of recommendations, there are some real challenges. And probably the first one that you might think of is the challenge of being able to bring together a broad range of stakeholders and people from a broad range of expertise to the table to discuss these issues, and be able to detect issues that a civil engineer might not necessarily be looking for. So that's really critical to meeting this challenge. Another key challenge, particularly in the post-disaster response and recovery period, is balancing the pressure of getting things back to normal, back up and running, with being able to detect opportunities to rebuild, to be more resilient and sustainable going forward. The example of the water distribution system, or sort of the green area in Christchurch, are ways to potentially implement that in practice. Another one is keeping an informed, educated public. It's another really critical component. I think the number of informational placards that I saw while we were in New Zealand that were just related to seismic hazards was really astounding. I've never seen anything like that before in my life. Keeping the public clued into why a particular historical building is closed for repairs, or why waterfront improvements need to be made at your local park. That's a really big part of keeping these types of hazards in the public consciousness, and at the end of the day, getting public buy-in. And that's something you absolutely need to implement these types of policies. And finally, last but certainly not least, I wanted to touch on the role of the Maoris, the indigenous Polynesian people of New Zealand, and that Maori concept of kaitiakitanga, or guardianship and protection of the environment, and how I almost don't want to say that it's integrated into New Zealand's emergency management strategy, but it sort of forms a really key pillar of their strategy. It's not so much outlining your resilience strategy and then checking with your local indigenous populations. It's involving those populations from the start, and it's a strategy that I thought was really unique throughout the world, and I think it's an aspect to resilience planning that communities across the world should really strive to achieve. So with that, I thank you for your time, and I think we'll move into the questions portion, and I'll turn it back over to Maha.
Thank you, Andrew, very much for the great presentation. We will take now a few brief minutes to answer some questions, and we have many questions here, and I'll try to I think we'll take one question for each speaker. So again, there's a panel on the right if you want to submit questions, and you can let us know which speaker you want to address the question to. The first couple of questions I think are for Anne. And I'm going to paraphrase here. I think I'm going to kind of put them into one question. So you talked a little bit about low damage systems, including dampers that were an opportunity to use when you're reconfiguring the built environment, when you're rebuilding the built environment. And so the question was on if you have any comments on preferable types of dampers that you learned through the study, and also potentially the availability of code information for designing these types of systems, and maybe base isolated system as well. So if you have any insight based on your study, if you can share that with us. Thank you. And I think you might be muted.
Thank you. Good questions. And I will say that I would guess Ezra is actually more clued into some of this, but I'll just say a few things. One is that the code aspect is absolutely the hardest thing about this. In my master's work was looking at a rocking system, and the hardest part of it is how do you make it into a system that can be easily integrated into the code. So that's the hardest thing. As far as different options for dampers, the use of the viscous dampers was really interesting. A lot of things might use more of a incorporating the damage aspect. So like the fuse, for example, that U-shaped fuse is trying to get damage to be the way that we are dampening the energy that's coming in. But this viscous option actually lets you use the velocity of that mechanism to get rid of that energy. So that was really interesting to me. Ezra, if you have anything else, go for it.
Yeah, perhaps I'll just touch on the base isolation side of things. It's a technology that has been around for a long time and has really started to gain some popularity in the last 20 or 30 years, particularly in Japan, a little more in New Zealand, and not as much in the US. And a lot of the issues in the US are related to some of the requirements we have. You need a peer reviewer if you want to isolate a structure. There's prototype testing that's required and production testing that's required, and some other hurdles as well, covered by Chapter 17 of ASC 716, and the dampers are covered by Chapter 18. So I'm not going to list companies that make those devices. There are a few out there, but things to consider if you're going to implement that type of system. I would say is what are your goals as a designer? Are you trying to limit damage so that you can be functional right after the earthquake? If that's the goal, then and a requirement, then it's something that you should look into more and strongly consider. If you're mainly concerned only with not having a huge amount of structural repairs, well, then the answer is it depends on where you are, the seismic intensity, and from a cost perspective, how much money you're willing to sink in up front.
Thank you, Anne and Ezra. The second question is actually for Ezra. If you can comment on the availability of a systematic approach for selecting retrofitting systems. I think you talked about that a little bit, and the question, I'm paraphrasing again, the question is about the availability of such an approach to kind of be able to implement these low damage technologies.
Yeah, I mean, I'm not aware of a systematic approach specific to retrofits. There certainly is the performance-based earthquake engineering approach and the peer integral where you can assess what really the impacts are on your design before and after in terms of things like deaths, dollars, and downtime that you know, for an individual building can miss out on things like if you have a taller building next to you that is quite vulnerable and could cause a cordon. But I think that where you start from is probably ASC 41 in the US, and then performance-based type approaches that look at probabilistically what's the likelihood of different damage, and you can compare that for different systems.
Thank you. The next question is for Andrew. You talked about liquefaction damages, and I think we have a question regarding how these damages were categorized into severe and minor, based on what you talked about in your presentation. What was the divide between damages that you would characterize as severe damages and versus minor damage?
Yeah, I think I'm not going to try and go back to that slide. That's not a rabbit hole anyone wants to go down, but that shows how it was mapped for that particular study. But typically, you know, there's obviously the no damage or no liquefaction categorization where liquefaction might have occurred below the ground surface, but you know, it would not have manifested. We don't get ground settlement or ground cracks or anything like that, or sand boils. Then there will be moderate damage where you might have some minor ground cracks or sand boils that don't necessarily have a strong impact on the performance of the sites or the structure that is sitting on that liquefiable deposit. And then we typically get into things like very severe surface manifestation. That's a situation where we're getting very large sand boils, significant ground settlements, and sometimes occasionally we'll also classify lateral spreading within that. It's horizontal deformations due to liquefaction. But oftentimes, I think there have been certain databases from New Zealand that sort of separate lateral spreading into a different damage category itself, and that's almost a different problem entirely in terms of dealing with damage to a structure. Lateral spreading can be really significantly damaging, and looking at it from an environmental standpoint, lateral spreading is kind of the mechanism that, when it occurs near waterways on the banks of rivers and streams, will drive a lot of that, both the sedimentation of small silt particles, as well as it's usually what causes ruptures to critical infrastructure, things like sewage lines, gas mains, things like that.
Thank you, Andrew. We have a couple of kind of general questions to any of the speakers. I think they're really interesting. I'm going to again try to put them in one question. So concerning the response of New Zealand to the earthquake in general, if you guys, based on your study there, think that this response is similar to a similar earthquake that would happen in the US, or if it's how different it would be. And if you would kind of consider differences in the government population relationship between New Zealand and the US, how would you rate that recovery process in New Zealand, and how would you expect it to be different in the US to a similar earthquake? Any of the speaker, or maybe all of you, maybe can comment on that.
I'll take a stab at that first. So one of the things that so I was on a project that did a study for the city of San Francisco for their tall buildings, and as we were trying to think about what San Francisco could look like with Cordons, one of the things that kept coming up is that it's not quite clear who would have the authority on how that process moves forward, who sets up the Cordons, who then manages the Cordons, and then who decides when they come down. Whereas in New Zealand, they were able to set up this kind of really coordinated system for addressing the recovery, the CERA, the Canterbury Earthquake Recovery Act. And so there's not quite a clear picture of how that would go down here in the States. It was problematic even in New Zealand with that ability to have such a top-down approach, but without a central entity or a way of having that authority here in the States, there's a question as to how that would play out.
I'll add, we perhaps have not had a truly large earthquake in California since 1906, but we have seen other disasters around the U.S., thinking of Katrina, Hurricane Andrew, Superstorm Sandy in the New York area. And I think what we have seen is that we have a tendency to build back the same way as we were before. And that's partially a function of the way that the financing works after disasters. And so that's one thing that I think may be a little different. I think New Zealanders were quite willing to build back a little differently and reconfigure the spaces in a way that made them more usable. And tying back into what Andrew had just addressed with liquefaction in rivers, in the Avon River in Christchurch, it raised what the floor bed was of that river, which means you suddenly have a wider floodplain than you did before. And they recognized this and were able to reconfigure the space around the rivers and put in park space where you previously had buildings, because you don't want something that is that close to a flood hazard. And that's something that I think we might struggle with a little bit in the US.
Yeah, just to add on to that, I think there is, there are just differences in the makeup of New Zealand versus the United States, and I also think I tend to compare New Zealand and Japan as countries that the seismic hazard is more or less ubiquitous at this point. They've had numerous significantly large events in the last 10 to 20 years. These are countries where pretty much the entire population is exposed to seismic hazards in some way or another. In the United States, we haven't had a really large event since 1994, 1989. And there are areas of the US that see different types of hazards due to flood or wildfire or what have you. So I think it's hard to move forward in terms of recovery and resilience planning, looking at just the seismic hazard in a particular area. I think the fact that the U.S. is so large and diverse and has a lot of different stakeholders and people with different concerns means you sort of have to push forward with a multi-hazard approach. You have to be able to push issues like flood protection, fire protection, as well as seismic resilience under the same sort of efforts. I think the country's too large and the needs of the people are too diverse to really see the type of focused effort on one type of hazard that you see in Japan and New Zealand specifically.
Thank you, Andrew. I think with that, we will wrap up the webinar. I'd like to thank again all of our speakers today and everyone who joined the webinar. I would like to remind you all that we would love for you to fill in the post-webinar survey. It helps us inform our decisions for following webinars. Professional development hours, if you're interested in them, the information will be sent to you in a follow-up email. And if you're interested in joining the Younger Members Committee, once again, you can go on our website, ymc.eeri.org, and fill in our interest form. And here are a few other links to learn more or join ERI. Thank you, everyone, very much. We hope you have a good rest of your day.
Thanks.